Good day to all. Today we are going to see about that Kirchhoff's law. What is that Kirchhoff's law? See the introduction of Kirchhoff's law and the Kirchhoff's voltage law, then analysis circuit of Kirchhoff voltage law, then we'll move about Kirchhoff's current law and analysis of circuit of Kirchhoff's current law. Likewise, we will see. First of all, we have to see the introduction of Kirchhoff's law, the history of Kirchhoff's law and the introduction, then types of Kirchhoff's law. See, this is the history of Kirchhoff's law. First described these two laws that became a central of electrical engineering in 1845. The law were generalized from the work of George Ohm. It can also be derived from Maxwell equation, but were developed prior to Maxwell work. This is the Gustav Robert Kirchhoff, German physicist. And the introduction. What is that Kirchhoff's law and how it will work? See, before we going to see about that law, a pair of law stating a general restriction on the current and voltage in a particular circuit. Then the first of this states that any given instant sum of voltage around the closed path or a loop in a network is zero. The second states that at any junction of path or node in a network, sum of the current arriving at any instant is equal to the sum of the current flowing away. This is the simple terms we can say that Kirchhoff's law. There are two types of Kirchhoff's law. First one is Kirchhoff's voltage law and another one is Kirchhoff current law. Here we will going to see about that Kirchhoff's voltage law, which is introduction and as well as the mesh analysis in that Kirchhoff's law. See, the Kirchhoff's voltage law is one of the fundamental law in electrical engineering. The other being is the Kirchhoff's current law. Okay, then this fundamental has a conversation of energy in a mechanics. For example, because of this KVL, it's really conservation of the electrical energy. These KVL and KCL are starting point of analysis of any circuit. Then this KCL and KVL always hold and are usually most of the pieces of information we will have about the circuit after the circuit itself. Then what is that Kirchhoff's law? See, Kirchhoff's law is nothing but it says that the algebraic sum of the voltage across the set of branches in a closed loop is zero. The algebraic sum of voltage is equal to 0. Here you can see sigma V across the branches is equal to 0. This is the main concept of Kirchhoff's voltage law. It's, you can see here, below is a single loop circuit. The KVL computation is expressed graphically in that voltage around the loop are summed up with the traversing the loop. You can see here if it is 10 volt and here it is resistance 1, resistance 2 and resistance 3 is here. Across to this resistance, what is the value? V1. And across this resistance, what is the value? V2. And across this resistance, what is the value? V3. That is the Kirchhoff voltage law, which says that the algebraic sum of the voltage at a point is equal to 0. So, if you are taking this and this and the voltage is equal to 0. The KVL equation is obtained by traverse the circuit loop in either direction and writing down an unchanged the voltage of each element, which is positive terminal is entered first and writing down the negative of the every elements of the voltage where the minus sign is first made. Then the loop must start and end at the same point. It doesn't matter where you start from that loop. The thing is, see, if it is the circuit like this, here it is the circuit, and here it is some volt like that. If you are starting the starting point over here, so you have to end the same point over here also. We shouldn't take a starting point in some other place, as well as we shouldn't take the end point in some other place. Both are should be in same places. Then note that a current direction must be in as assumed. The assumed current create a voltage across each resistor and fix the position of the positive or negative sign so that the positive sign convention is obeyed. See, first of all, we have to create that assumed current directions, as well as if we are thinking that this current flow will flow like this means we will take as a positive means. Then if it is in opposite direction, see, if it is in opposite direction, we have to take this current as a negative one. Likewise, we have to take positive and negative sign over the problems. Then the assumed current directions and the polarity of the voltage across each resistors must be in agreed with the passive sign convention for a KVL, Kirchhoff voltage law analysis to work. Then the voltage in the loop may be summed in either directions. It makes no difference except they change all the signs in the resulting equation. The thing is, we have to sum all the voltage across the resistance V equal to IR or I equal to V by R we can take, and we will sum all those things. The thing is, we can sum all the elements, but main we have to give the correct signs. As I said before, we have to give the correct signs. If it is like this, we will take this as this rotation as this way as a positive sign. Then the opposite way should be a negative sign. If we are take this direction is a positive, then we have to take this direction as a negative one. So the taking of sign is very important in that Kirchhoff's law. Here the summation of voltage terms may be done in either direction. We can do this direction as well as to opposite direction. You can see here, if we are adding here, we'll see the 10 volt is here. We'll take this voltage across this resistance, for example VR1, and this VR2, and this as VR3. Then the sum of this all we can take it as a VR1 plus VR2 plus VR3 minus 10 equal to 0. Likewise, this is in the opposite direction. For example, if it is in this opposite direction, here the current will flow like this. If we assumed, then what we have to do, we will take this as a negative directions. See, you can see here, this is a voltage across the resistance are same over here also, but here it is the negative signs come in front of that voltage, minus VR1 and minus VR2 and minus VR3. This sign will get a reverse of this sign. Here it is a minus because the current is flowing through negative to positive. So here we'll take as a negative sign. but here it will go for positive to negative. See here the current will flow like this. If the current is flow like this, we will take this positive to negative. So this 10 will become a positive one. So the sign is very important when we are doing this Kirchhoff voltage law. These are all about the Kirchhoff's voltage law. Thank you.